theory about the world that I present in this book is not something that I have invented out of the blue, but it's based on something called quantum field theory in physics, and then it is extended with what I call a qualia field theory for consciousness. So it's quite broadly recognized field theory for the physical world, but then extended with the field theory for the conscious world, which I have constructed then based or inspired by the field theory in the physical world. And then I have this theory about how they are related, and that's a new way of thinking about the mind and consciousness, which solves a number of classical problems. But to understand any of this, we need to take a look first at two things, or two topics from physics, and that is particle physics and field theory. So we start with particle physics. Many people know the old model from Niels Bohr on the atom and how that's composed by protons and neutrons in the core and electrons spinning or orbiting around. And this still works as an approximation, but in detail it's outdated. Now there's the standard model of particle physics, which tells us that there are many different elementary particles. And by elementary particle we mean particles where, as far as we know, that's the simplest particles there are. There's no parts or components of them. And in the standard model of physics, particle physics, the electron is still an elementary particle, but protons and neutrons are not. They are combinations of up and down quarks. So up and down quarks are elementary particles, and if you have two up and one down, that corresponds to the proton, and two down and one up corresponds to the neutron. In addition then, you have particles also for the physical forces. So one particle mediating each of those. You have the strong and weak nuclear forces, and then there's the electromagnetic force. And I say perhaps gravity, it means there's this hypothetical particle called the graviton that might be mediating gravity, but this hasn't been discovered, so there may be another explanation of gravity. But the general picture then, at least, is this: all of the physical things and how they move and relate to each other can be explained by these elementary particles. It would then be possible to say, or to think of the physical world as made up of particles, that you take these elementary particles and, like Lego bricks, you just build bigger and bigger things until you get sofas and chairs, etc. But there is an alternative way also of thinking about the world, where you say, instead of the world being composed of particles, it's composed of fields. And a field would then be something that has a specific quantitative value at all points. So for instance, we can think of the whole universe as a temperature field, or just the atmosphere or something, but you could do it with the whole universe and say that for every point, anywhere you go and look, you can put a numerical value for the temperature at that point. If it's in my body, it could be 37 degrees Celsius, outside 20 degrees Celsius, out in the universe maybe 273.16 minus, etc. So anywhere you can put a temperature value. But the same area, for instance, then the atmosphere on the Earth, could be defined as a wind field. And we say, okay, we want to have a number now for the wind in each point. So we put one number for the strength of the wind, how strong is the wind, and one number for the direction of the wind. And we can do that in all points. Or you can put 0 if there's no wind. And again, in the same area, we can say now we think of this as an electromagnetic field, and if there's electromagnetic currents, we can give it a value, or we can say that it's 0. Gravitational fields, we can have then how strong is now, or how strong is the gravitational pull in this point, etc., etc. So you can have many different types of values then at the same place. Thinking in this way, it's also possible to think of particles as field. Instead of saying that there are many electrons at an area, you can say that there is one big electron field, and there's an equation for this field. So there's a field equation for the electron field, but there's also a field for each of the particles and an equation for each of those particles. And these equations will then determine what the values are at the various points that we connect to this particle. So the idea then is to think that instead of thinking that, okay, at this place we have an electron and it has these certain properties, it has charge of -1, it has a spin of 1/2 and a mass of 9.1 times 10 to the -31st kilograms, you could say, instead of there being one electron here with those properties or with those values, we can say at this point we have the value for charge at -1, we have the value of spin on 1/2 and the value of mass 9.1 times 10 to the -31st, and that corresponds to there being an electron there. Why it may seem much simpler to just think that there are particles with properties instead of saying that there's a field that has a lot of different properties, a lot of different places. But if you think of particles as actually being collections of values in a field, then we can solve a lot of problems that we get if we think of the world as being composed of particles. Because sometimes particles behave in a very strange way. It seems like the same particle has been moving in two different places, or sometimes you have a collision between two particles and suddenly there are other particles there, and we can't understand how could that happen if they are elementary. Where did that particle come from? Did it hide inside, or how shall we understand this? But it's much easier to see if you understand that, oh, there were two fields here interacting. And since we want to conserve energy, etc., the energy and the values changed, and then we got the values that that correspond to another particle. So instead of now there being one electron and one photon, maybe we have two photons and etc. That's no problem if there are fields interacting, but it's very difficult to understand if there were particles interacting. So this is why it's helpful to think of there being fields instead of there being particles as the fundamental entity. So the idea then is that we have all these physical things like sofas and chairs, etc., but these can be reduced to atoms. That's a common thought. But in turn then, all the atoms can be reduced to elementary particles, and all the elementary particles can be reduced to combinations of the properties spin, charge, and energy/mass, since they are equivalent. So you get a massively complicated picture reduced to a very simple picture in this field approach. This raises an interesting question of whether there are even deeper laws and deeper fields, because most physicists will say today, well, we think of the field theories as effective field theories. They work well at the area or level that we are investigating, that we can, because of the technology that we have, the energy we have and can use, etc. But I think many of them will assume that there are deeper fields, or at least they would hope so. I've heard many physicists say, hopefully these different fields for the different particles, the different field equations, etc., could be reduced to one fundamental field and one fundamental equation explaining how you get all the different particles or the particle fields then and their interactions. Several philosophers investigating physics will also suggest that, well, these concepts of spin and charge and energy and mass can be reduced to description of motion. Because if you ask a physicist what is spin actually, or what is charge, etc., they don't have this ontological philosophical explanation or theory about what spin is or what charge is. They just define them in light of how they move and relate to other things. So spin, for instance, there isn't a thing inside a particle that is spinning. It just describes how particles with different spin will be related at a point, or how they will move through different areas, etc., going up and down depending on their spin. So it's a description of how they move. Same with charge. There isn't something that is positive or negative. We could change those terms. It wouldn't matter. But we say now that the charge will make them either attract or move from each other. And that's the point with the charge again. And the same energy mass will explain how they move. So it seems that it's possible to reduce even these values, then different kind of qualities, into descriptions of how, by what strength, what force is something moving in what direction. At any point we can describe this. So to summarize so far, we have good reason to believe that the entire physical world can be reduced to some simple rules that govern some simple physical values that can be found then at any point. And this is the background stuff that we need to bring along now as we move on to the next chapter.